Okay, so this time we're going to look at the last one on that handout, the question 7. Now, and the reason we're going to do this one is simply because there's variables in it, but we do it exactly the same as if there was numbers. Okay, so you've got two ships, A and B, and they're moving with constant speeds of 2u and u respectively. So we know the speed of A is 2u and the speed of B is u. Now, speed as opposed to velocity. At a certain instant, B is 2400 metres due east of A. So A is at the origin, and B is moving northwards. So that's its velocity direction. You've got to show that A must move in a direction 30 degrees north of east in order to intercept B, and then find the time it takes to intercept it. Well, A is obviously going to head off in that direction if it's trying to intercept B. Anyway, we'll see. Interception or collision, same idea. So let's get all our information. What's VA? We have no idea what the velocity of A is. I only know its speed, so I'm going to say it's AI plus BJ. But because I know its speed, I know that the modulus of this, which is the square root of A squared plus B squared, is equal to 2u. And if I were to square both sides, that would give me 4u squared equals A squared plus B squared. Okay, so that's a useful little equation. I'll leave that there because we're probably going to have to use that. Right, so what about the velocity of B? The velocity of B is heading northwards with the speed of u. So this is going to be just 0i plus uj. Okay, what's the position of A? The position of A is at the origin, and what's the position of B? It's 2400i plus 0j. Okay, so I will, to show that if they're going to collide, then obviously the slopes of the relative velocity must be equal to the slopes of the relative displacement. So what's my VAB? VAB is going to become AI plus BJ minus 0i plus uj. Okay, I'll subtract the i's and keep them together. So a minus 0 will just be ai, and b minus u, I'll keep that together. I'll group those coefficients, and that's the j component. Okay, what's the RAB? So the RAB will be 0i plus 0j minus 2400i minus 0j, so that's fine. Okay, so if they're going to collide or they're going to meet, then their slopes will have to be equal. So what's the slope of this one? It will be b minus u over a, and the slope of this one, of course, will be the j's over the i's, 0 over minus 2400. Okay, so for a collision, let's equate them. So if there's going to be a collision or an interception, b minus u over a is equal to 0 over minus 2400. When I cross multiply, this will become minus 2400b plus 2400u is equal to 0. A times 0 will be 0. And then 2400u will be equal to 2400b. If I bring that over, so obviously b is equal to u. Okay, so if I have B, I can now find A. So I'm going to use this value for B, substitute it into this nice little equation up here, and that will give me an expression for A in terms of U. So 4u squared is equal to A squared plus U squared, which means that 3u squared is equal to A squared. So A will be the square root of all of that. The square root of 3 times U, or you can leave the u squared inside the square root, which makes it a bit messier looking. Right, so what's the velocity of A then? My velocity of A is therefore root 3u in the I direction plus u in the j direction. Now, the question asked me to show the direction A is moving in order to intercept B. So to get the direction, remember we take the velocity. So this would be root 3u in the I direction. It would be that kind of direction here. If I call this angle alpha, then I want to find the tan of alpha. So the direction would be the tan of alpha, and then I could find alpha. So of course, if I draw a right angle triangle around that vector, This is the I component, which is root 3u. This is the j component. So to get the tan of alpha, it's the j's over the i's, or the opposite over the adjacent. U over root 3u. The u's will cancel, so that will become 1 over root 3, which means that alpha is equal to arctan 1 over root 3. And if you look in the calculator, or if you check your log tables, you'll see that the tan of an angle that has a value of 1 over root 3 is 30 degrees. So alpha is equal to 30 degrees. And we can see that you're going east 30 degrees, you're going east and then you're heading north 30 degrees. So it's east 30 degrees north, or you could say 30 degrees north of east. Okay, and the last bit is find the time to the collision. So the time, of course, is the relative displacement modulus divided by the relative velocity mod. Okay, now my relative displacement I already know. T is equal to, the RPQ is the minus 2400 on the I plus 0j. So I'm going to get the modulus of that, and I'm going to divide it by the VPQ, or the VAB rather, sorry, not PQ, they're ABs this time. Okay, so my VAB is this fella here. So VAB is equal to AI plus B minus U on the J. Now AI I already know, I found that, and it was root 3U. So this becomes root 3u in the I plus b I found to be u. So this is then u minus u, which of course is 0j. Okay, so I've got minus 2400 on the I plus 0j. I want that modulus, and I'm going to divide it by the modulus of root 3u in the I plus 0j. And that gives me the time to interception. This will become, of course, the square root of minus 2400 to be squared, divided by the square root of root 3u, all to be squared. So this just becomes 2400 over root 3u. And you can just leave it like that. That's in seconds. It will often, if there's a variable, you'll often get a strange fraction. Don't worry about that.